Hello everyone. Today I'd like to continue visualizing the states data set. We will draw a histogram, interpret a histogram, and we will talk about the law of large number and central limit theorem. Okay, so I will start with importing NumPy and Pandas and Matplotlib. And I'm going to define the path directory to the data set. Then I'm going to read the data set with all the columns the way we saw this past couple of lectures. Okay, so now I'm going to use only Panda data frame to draw a graph in here. So we are going to define two attributes of plot, axis and figure, and then PLT is the mat plot. We are going to create subplots. Later you will see how these subplots are helpful. And I'm going to define the figure size that I'm creating, figure size equal to 6 and 5. The width is 6 and the height is 5. And then I'm going to define DPI to be 100, which is resolution. So by default, they are a certain value, and then we can increase or decrease the resolution or figure size. That will have effect on the graph that we are creating. Okay, so I'm going to say data set and graduate percentage, which is one of the column in dataset, and I'm going to create a histogram, and then I'm saying the number of bins 4. So as you know, this is the numerical variable and this is the dataset I created here, and then I'm choosing the column from my dataset and I'm going to create a histogram of this column of this data set, right? So the way I'm drawing a histogram here is based on the data frame I created. There are different ways of drawing histogram. So this is one of the ways. So now I'm going to copy one of these and then say this one is another column. So I want to have 2 histograms, right? And then I'm going to draw a histogram of these 2. Okay, so now because this one is not that clear for you, maybe I'm going to cut this, bring it here and have it here, because I'm going to do something else. So what I'm going to do, I'm going to create a sub data set from the data set I have. How can I do that? I can use LOC, and then I say I want all the rows and I want 2 columns, both of the columns that are numerical variables, this one and this one. Okay, so in this way, let's see how our data set, sub data set look like. So I have just 2 columns of the data set. So that's why I'm calling this sub data set. Means this is a subset of this data set, right? Creating a subset of the original data set. With only numerical variables. Okay, so I don't want to print it anymore. It was just for your your understanding. Okay, so what I'm going to do now, so this is a data frame. I'm going to use this data frame dot histogram. So what is the difference between this one I'm doing here and this one? This one I said from my data set get the column, for each column draw a histogram, right? Here I say draw a histogram for the whole data set because I have just 2 numerical variables here, right? And then it's going to be just histogram for those numerical variables. And I'm going to have an argument here, bins are 4. Okay, so I will have 2 histogram here. One is the minority percentage, another is graduate percentage. I'm going to remove this to show you what happens. So by creating these subplots, I created different figure. So this is an empty figure, this was an empty figure, and then because I don't have anything for the first, this one is still empty, right? So as you see, it shows the subplot that is being created. 1 here, 2 here. Okay, so we are going to remove this and say we don't need this because we are showing only 1 graph. Okay, so let's change the number of bins to 5. What happens? Let's try to change it to 10. What happens? So what is the bin? Bin is the class interval on the x-axis for each of these histogram. So what are the x-axis? X-axis are the percent of graduation in each state, and here minority percentage on the x-axis. What is the y-axis? Y-axis is the frequency. So this frequency tells me, for example, there are just 2, look at this one, there are just 2 states that have the percent of high school graduation, let's say from the minimum percentage to like, let's say 71 or 72, right? But there are 14 states that have a percent high school graduation from, let's say 86% to 8% approximately. We can design this graph to be more specific and have lines that exactly, shows where each bin are going to end or start. Okay, so now there's a really interesting question here. Let's look at this. So I had 4 bins, right? And then as I increase the number of bins, the class intervals are getting smaller and smaller, right? Depends on the percentage, the range of percentage I have. What is the range? Range is from minimum to the maximum. We call that range. So how do I choose the number of bins for histogram? That's really kind of interesting question. There are different methods that talk about the number of bins and how to choose that. One of those methods is Friedman method. How to choose the number of bins in histogram. Okay, as I said, one method is Friedman method. Okay, so the Friedman rule states that actually this is a very robust rule and works very good in practice. So it says the bin width, what is bin width means the class interval for each of this bin. Look, this is the first bin starts here and then ends here. One important note you should always know, the width of bins, this bin, is exactly same as the width of the next bin. The width of next, all of them have exact same width. So the width of bin is going to be calculated in this way. H equal to 2 times IQR. So now what is the IQR? IQR is interquartile range, which is Q3 minus Q1. So now I hope you know what is Q3 and Q1. Q3 is the third quartile, and then Q1 is the first quartile, and then Q3 is the third quartile. So what this first quartile says, it says 25% of observations fall on the left side of Q1. When I say on the left side of Q1, means starting from minimum, right? And then median is the midpoint. Then Q1 is somewhere between minimum and median, right? And then right after median, in the middle of way, between median and maximum, we will have Q3. So Q1 is showing that 25% of data sets are from minimum to Q1. Then Q3 says 25% of observations are from Q3 to the maximum. And then what is Q2? Q2 is the midpoint or median itself. And what is median? Median says 50% of observations fall on the right side of median, 50% of observation falls on the left side of median. So all of this is provided that all the observations are ordered from minimum to the maximum. An easiest example will be the student's grade. In a classroom, let's say we have 25 students, their grades are ordered from minimum to the maximum, right? If we order the grades from minimum to the maximum, there are 5 important numbers or values that we are always interested. One is minimum, another is maximum. These are so clear, right? The minimum grade, maximum grade. The next number, which is very important, is median. Median says 50% of a student's grade fall on the right side of midpoint grade, 50% of students' grade fall on the left side of the midpoint grade. So that would be the midpoint grade if all the grades are ordered from minimum to the maximum. And then between minimum to the median, we have the first quartile, and then from median to the maximum, we have the third quartile. So what quartiles do? Quartiles divide the whole data set to four parts, right? 4 parts. That's why we call them quartiles. So these 5 numbers that I was talking about, minimum, maximum, median, Q1, Q3, these are 5 number summary. 5 number summary is very useful to describe and explain our data set. Actually, I can say it's useful to describe, if I want to say it correctly, describe our variable. So what is the variable when I had an example of a student's grade? The variable is a student's grade. A student grade is the characteristic of individuals. Individuals are the students, right? So the variable could be a student's height, right? A student weight. As long as these variables are numerical, we are able to find 5 number summary for that. Okay, so let's go back to this one. Now we know what is Q1, Q2, Q3. Now we know what is interquartile range, Q3 minus Q1. And then one point here, we use interquartile range to find the influential point or outliers. Okay, so the method that tells us what is the width of bin says 2 times of interquartile multiplies to n, which is the number of observations for example, in this study we have 50 states, right? In the example I had about a student's grade, students will be the individuals, right? 25 students. So n is the number of observations, or in parentheses, let's say number of individuals, right? Okay, let's go back to the formula. Now, n raised to -1/3. So this is h. H gives us the bandwidth or bin width, means from this point to this point, right? Which is same for all the bins in this histogram, for example. Now, what is the number of bins? How do we find that? We use that H. Let's make this capital H so it's more noticeable if I write down capital. So max minus min divide by H gives you the number of bins. Okay, so in this way we find the number of bins. So now that I chose 10, 12, these are just the arbitrary numbers that I'm choosing. I could be more specific and use the rule and find the number of bins in this data set. And as you see, if I change the number of bin, the shape is changing, right? So it's very good to have a correct number of bins to show the histogram rather than choosing arbitrary number without even thinking about the effect of number of bins on the shape of histogram. Okay, so I hope you understood how we explain the x-axis and y-axis and what is this histogram, because the histogram is very different from the bar graph. You can investigate this and see how they are different. Maybe after this video, when I'm explaining another bar, showing another bar graph, I come back here after this example. I will come back here and explain and show you what is the difference. The main difference, let me write it down here. The main difference is that bar graph is only for categorical variables, but histogram is only for the numerical variables. These are very important. As I mentioned once, it's very important to know what is the type of variable you are dealing with, because categorical variable has their own graphs. Numerical variable have their own graphs. So if you use bar graph to show a numerical variable, it doesn't make sense at all. And if you show histogram to show if you use histogram to show a bar to show a categorical variable, it will not be understandable at all. Okay, so now how do we explain or interpret the histogram? You know what? Actually, before doing that, I don't want this lecture to be boring and just lecturing. I personally love coding. So let's see how we can draw another histogram using the same data set, using matplotlib. If you remember, I said this method is only for only uses pandas, right? Let's see what's the difference between histogram in pandas and using histogram in matplotlib. Okay, so what I'm going to do, I'm going to again define figure axis plt dot subplots. I'm going to create one row with two graphs, and when I say one row, let me explain it here. One is for row, two is for column. Let me draw a figure and then I will show you what I mean. And then let's adjust the figure size is equal to, let's for all of them have 6 and 5. It seems very good. This size is very good to record a video. I like it. Figure size, what else? DPI is equal to 100. This is not 100, definitely. And then this one is equal to false. I will change it to true to show you what happens when I'm drawing the graph. Okay, so I created two axes. Now the first axis, which has index 0, we are going to draw a histogram for that. So look, I'm using the axis that I defined using PLT, which is the method in which is matplot itself, right? Okay, and then I'm going to draw another, assign another histogram to the next axis. First axis, second axis. Okay, what I'm doing here, I am using my original data set and I'm going to get the graduate percentage don't copy paste, that's not good. And then it's funny, I'm that kind of person. I said don't do this, that's not good, and I'm doing it myself. Okay, so I'm just saving time here. Density is equal to true. Number of bins, let's say set to 5, and then again don't do this. Okay, am I done? Yes, I'm done. So what I did, I created what is this? This graph and this graph. One is the percentage for graduation. This is minority, right? And then using density true, it will normalize the axis for me. If I say false, let's see what happens. The percentage are showing here. False. I think this is more beautiful. Okay, I'm going to write down a note for you here. Density changes the y-axis. If it is true, changes the values on y-axis. If it is true, then the values are normalized, right? And then what else I explained here? Oh, I said let's try this. So this is false, right? Let's make it true. True. Okay, do you see the difference? Let's make it false. Look at this, the y-axis. So now we have y-axis for each of them. This one. Another note. This one will dedicate values to both axes. If it is true, we will have only values on one axis. Okay. There's another argument that I wanted to show you. Tight layout equal true. Let's see what happens. Nothing happens, right? But let's change this density to true, because if I change the density to true, I will have a big numbers here. Look, now there's more distance between these two lines, even though the number is big. If I change this to false, you will see they are colliding kind of. So if we have numbers for y-axis that are longer, we must set this tight layout to true, so our two plots are distance properly, right? So here we use we draw histogram using matplotlib, right? And then now we know this one true will create an appropriate distance between two graphs. Okay, so now let's talk more about histogram. How to interpret histogram. Well, to interpret histogram, we are going to look at three or four main things. I'm planning to draw okay, here. Did you see when I click on this output, it opened it for me this way? Okay, so you can toggle this, I know, using this one. I think so. Current output. So this one is like scrolling down. This one changes clear. I remember it was something like toggled, something like that. You should go through that and see how you can change that. Some of I know for a fact you will do that. This is a new version of Jupyter Notebook that I downloaded recently, and they have changed lots of things. Okay, let's go back to the topic, how to interpret. Did I write it down correctly? No. Interpret histogram. Okay, so when you want to interpret histogram, you will look at the overall pattern. You will talk about the center of histogram, which is median and mean. You will talk about the variability, or we call that spread. You can use IQR, range, and all the measures of variability. 3. You will look for an outlier. 4. You will look at the shape. This is the most important one. Shape can be symmetrical, can be right skewed, or can be left skewed. Okay, so right skewed or positive skew distribution. What is that? Something in this form. Means if we draw a curve on top of all the bins or class interval of the histogram in this way, the right side of histogram will be extended and we will have a skewness on the right side. If we have a skewness on the right side, we say the graph is skewed to the right or positively skewed. If we draw a curve on all the bins and then the left side is extended and the skewness is on the left side, we call this the left skewness. So what do we need this for? So if I know a graph is right skewed, it means the frequency, the highest frequency happens on the left side of graph. Means the percent of minority percentage are here around this percent for all the stages. And there are a few states have the higher minority percentage, just maybe 1 or 2 states. Let me change this to false. percentage is, or frequency is better. False. Okay, so now makes more sense. Okay, look, on this side we have more frequency, means there are more states with the percent of minority in their state around 20 to like say 10 to 30%, right? And there are few states, one state or two states that have highest percent of minority people, right? So this is the way the right skewed graph helped me to explain the graph. What this one says, the left skewed, it says there are more states with highest graduate percentage, and there are a few states with the lowest graduate percentage. I hope this helped you, and I'm going to show you something that I always show to my student, my statistics student. Okay, so right skewed, left skewed, symmetric, right? Okay, so on symmetric histogram, these are all histogram. What this curve is, this is a density curve that covers all the bins or class intervals on the histogram. So if we have a symmetrical shape, which is this one, what that means if we draw a line in middle of distribution, the right side is the mirror image of the left side. This is symmetrical with one peak. We call this peak. This is a bell shape symmetrical distribution. We call this normal distribution. Normal distribution is a distribution that is bell shaped, symmetrical, right? And then later we will talk about a standard deviation and median. And then median and standard deviations are the two attributes that explain the normal distribution. Okay, so anyway, we come back to this. For normal distribution or symmetrical distribution, median and mean are exactly on the same place. Median mean are both on the x-axis. Please pay attention to this. It's not here. The height shows the frequency. This x-axis is the one that's showing the, for example, a student's grade, percent of high school graduation from minimum to the maximum, right? So the median falls here. Mean falls here as well if we have a symmetric distribution. So, conclusion, in symmetric distribution, mean and median are exactly same. Okay, so right distribution, right skewed distribution. Median is always around the peak, either right skewed or left skewed. Median falls around the peak, means here on x-axis, here on x-axis. For right skewed or left skewed, mean is going toward the skewness. Mean is going toward the skewness, right? So mean is here, mean is here. Okay, so now there's a question I always ask my student. Well, which one is bigger in a right skewed distribution, mean or median? Think about this. And if you paid attention to what I said so far, you will be able to explain this and you will be able to know where exactly the median is. Okay, so now we are talk about the participation point. Okay, so for this lecture, I have some participation point for you. Okay, 1. I want you to again think about the Where's that? Where that picture went? Okay. I want you to again think about this and answer my question. Which one is have a bigger value in a right skewed distribution? So the first question is about right skewed distribution. Which one is bigger, mean or median? Then the next question, in left skewed distribution, which one is bigger, mean or median? You can look at these graphs and think about this. Okay, I will continue talking about graphs and generating the histogram, more beautiful histogram, in the next video.